Good day, yes. Um, this is the next on our electrolysis. This is the continuations of the electrolysis, which is known as the applications of electrochemical cell. So, in this electrochemical cell, at the end of this, we will be able to know the distinctions between the primary cell and the secondary cell types of electrochemical cells. So, the applications of electrochemical cell. Now, let us start with the applications of electrochemical cell. Now, electrochemical cells are widely used to generate small currents of electricity for every purpose and industrial operations. That is, whenever we have a cell, it is generally used for what? For every purpose. Maybe widely used to what? To generate what? A small current, or to generate a large current within what? Within the vicinity. Now, to now proceed, we have primary cell. A primary cell is that it's not rechargeable. E.g., we have Daniel cell. Then a secondary cell is a cell that is rechargeable. E.g., we have lead acid accumulators. Now, the difference between the primary and the secondary cell. One, we have a primary cell cannot be rechargeable, while secondary cell can be rechargeable. Often we have to know that what primary cell, there is no way we can recharge primary cell, but secondary cell, we can what? We recharge it. So, in primary cell, chemical reaction is reversible. That is, in primary cell, there is no how we are going to reverse the what? The chemical reaction. While in secondary cell, chemical reaction is reversible. A primary cell is cheap and easy to use, while secondary cell is what? Expensive and what? Complex in using. Now, for example, look at what? Our rechargeable now. That one is very common, which you can see. The battery inside the rechargeable, they are known as what? A secondary cell. Likewise, the battery in our phones, because provided we recharge it, they are known as a secondary cell. So now let us look at 3. A primary cell is cheap and easy to use, while secondary cell is what? Is expensive and complex in using. So it is what? There is no how. If you want to buy, they are what? They are very expensive. While primary cell, they are very cheap to get. Anywhere you can get it. So now we have primary cell. Primary cells are commonly found and used in most of the electric toys, clock, wristwatches, domestic, remote control, etc. If you look at your wristwatch, there is a battery used in your electric watch or in your watch. That battery, it is known as what? It is for primary cell. Whereby whenever the chemical present in it, wherever it has what? It has to. There's no how you can recharge it. Definitely you have to throw it away. But there are some wristwatch now, whereby if you are using it, you have to what? You have to charge them. Those ones, they are not what? They are not primary cells. Are you getting now? So now, secondary cells are commonly used in starting, lighting, and ignition in vehicles. They are also the uninterrupted power supply. That is, they are what? UPS. It is now types of electrochemical cell. 1, we have what? Daniel cell. Daniel cell, it consists of copper vessel filled with saturated solution of copper 2 tetraoxosulfate 6 and a porous pot filled with a zinc tetraoxosulfate 6 solution. Where a zinc rod is immersed in, the initial EMF produced by the Daniel cell is about 1.1 volts. That is, those battery watch that you see, they produce only 1.1 volts. So 1.1 volts, that is, it has to replace once the chemical in it is what? Used up. So if the chemical inside the battery has been used up, you will remove it and throw it away. definitely it is no more useful. So now we now have the cleansed cell. The anode and the cathode is zinc rod and carbon rod respectively. That is, the anode here is zinc. The cathode is what? The cathode is carbon rod. So the electrolyte is an what? Is an ammonium chloride in solution or a paste form. At the anode, the zinc atoms lost 2 electrons each to dissolve in the electrolytes as positive charged zinc ion. The electrons which are released pass through an external circuit forming useful work such as lighting up a torch bulb before arriving at the cathode of the cell. We remember when we are very small, whereby we normally do lighting up a torchlight, we will buy a bulb, then we will now use what? A wire to twine the bottom of that bulb. We will now straight it and what? And fix it up, such like this. This is the bulb. We will now swing a wire at this bottom. Now the wire will now pass like this. Then we will now have what? We will now have the cell, the battery cell. This is the what? This is the cell. So as it is, once this wire, we now bring another wire. We will now use it to touch the bottom of the cell. So once this torchlight, once this bulb touches the end of what? Of the cell, what will happen? It will bring out what is known as the light. It will bring out the light. So in that is what is being explained here. That what? A circuit forming useful work, such as lighting up a torch bulb before arriving at what? At the cathode. This is the anode and this is what? The cathode of what? Of the cell. So in this case, we have what? Zinc. That is, the zinc ion will now produce what? Zinc ion, which is what? Oxidation. Then ammonium, we have what? Ammonium ion, we have what? Ammonia plus what? Hydrogen, which is now what? Reduction. Once it is being what? Once it is being loose, therefore what will happen? We have to replace it. So now this is the diagram of this cell, this battery cell. This is the diagram. If you look at it now, we have here the cathode, we have here the cathode, and what? The anode. We have the cathode, and we have what? Here we have what? Anode. So if we can have on the cathode to be what? To be positive and the anode to be negative. So the down here is known as what? Negative. That we have. The down here is known as what? The negative. That's why you can now see what? You can now see the diagram that points at what? At the wet region there, which is known as what? The anode. While we now have what? The head of this place, which links with this what? With this rod. It is known as what? The cathode. So by so doing, we now have lead acid accumulator. Lead acid accumulator. Lead acid accumulator. This is the example of the battery that we use in putting into our cars. The battery that our car is using. The battery that what? That our machine is using. They are known as what? Lead acid accumulator. It refers to as a car battery. It is often changed by what? By passing the direct what? Current through it. If we want to charge it, we are using what? Direct current. Our NEPA office, with our NEPA light, we use it what? To charge it. The charged cell can be then produce electric current required. So if you now charge it, it can produce what? It can produce light that is being what? Required. The electric that is being required. So we now The cathode of the fully charged lead accumulator is lead, is what is lead 4 oxide. Here we have the word the lead 4 oxide. And its anode is what? Is metallic lead. The electrolytes is dilute tetraoxosulfate what? Sulfate 6 acid. Now we now have here, we have lead ion. Then we now have lead plus what? Sulfate what? 6 ion. So this is what this is what it gives us. So by so doing, I believe we have come to the end of this so-called what? Electrolyte. So my viewers, what you need to do for me, please and please share and like. Let others to benefit from what you are seeing. Let them too have the taste of what you are gaining, so that you as well, you have done good in your life. So please share, and God bless. Thank you.